Hello, today we are looking at this idea of objects being balanced or not, or whether they are stable in terms of toppling over or not, and we're going to combine our understanding of center of mass, a little bit of moments, and we're going to see if we can apply that to this higher tier content for whether objects are stable or not. Now, to start us off with, we have a little example here of a box that's just standing on a flat surface, and you can see that this box is unlikely to topple unless someone came along and pushed it or did something to it. But what we have is this box, and we have a line of action of its weight towards the center of the earth, about there. We call this the line of action of its weight, and it comes from it's centered at its center of mass. So the center of mass for this object is round about there. Now, what would happen if I was to tilt it slightly? Would that tip over? It looks unlikely that it will, just by eye. What if we tipped it a little bit more? Would it tip over? It looks like it possibly could, but we can't really tell unless we take into account this idea of center of mass and the line of action and the base. So how do we do that? Well, the rule is that if the line of action of the weight lies outside of the base, we will have a resulting moment, in other words a resulting turning force, and the object will topple. So let's have a look where our center of mass is. It's about there for each of those diagrams, and if we look at the line of action of the weight for this one here, straight downwards towards the center of the earth, and for this one straight downwards towards the center of the earth, and you can see in actual fact this object here is going to topple. This one will stay upright, and this one obviously will stay upright. So the whole idea is being able to explain in terms of the line of action of the weight whether there's a resulting moment or not, and whether it will topple. And remember, you've got to combine the idea of center of mass with this explanation as well. Now, you could apply this to an idea like this. We have a bus that's driving along. What happens if the bus was to drive this way on a slope? Would it topple over or not? Well, again, we have to look at where the center of mass is, and in actual fact buses are designed to have a very low center of mass. So you can see that if we tip this bus to this degree, the line of action of the weight is still within the base of the tires, and this won't actually topple. There is a possibility of this center of mass getting higher, that center of mass getting higher, and that would happen if we had a lot of passengers on the upstairs deck. But this is taken into account, and so buses have a very low center of mass, so that the line of action of the weight is most likely in most situations to be going through the base. Another couple of examples that you might want to consider is a person standing. You can see with the feet close together the base is quite narrow, so this person is more likely to topple over. The center of mass for this person is around about here, so you can see around about this point this person is likely to topple over. That's just the tipping point right there. However, if the person squats down, feet far apart, that has two effects. That lowers the center of mass of the person, and it also widens the base. So if you look at the base now, it's much wider, and this person would have to be toppled quite a long way before they fell over. So they would have to go all the way there and probably beyond. There's the tipping point for the person there. Seems to be about right. It's just about the tipping point there. So the person has to tip much further before they would topple over, and that's because we have a wider base and a lower center of gravity. Another example is a bicycle. This would very likely topple over because the base is very narrow. It's just a tire. But what we could do is add some stabilizers, and again that has the effect of increasing the width of the base. The center of gravity for this is probably roughly about here, but you can see again adding the stabilizers just means that the base is much wider, and group is much wider, and we would have to topple the bike or tip the bike a lot more before it was going to fall over. Okay, so there's a couple of examples. You should be able to explain whether an object is stable or not based on an explanation like this if the line of action of the weight lies outside the base or not. Okay, so this is for the higher tier. You should be able to explain stability of objects. Thanks for watching, and I'll see you again soon.